Alright, so in this problem I have 3 to the power of x is equal to 30. So to solve this problem, I'm going to first start by dividing both sides by 3. So now I have 3 to the power of x over 3 is equal to 30 divided by 3. So this simplifies to 3 to the power of x over 3 is equal to 30 divided by 3, that's equal to 10. Now, if you guys already didn't know, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x over 3, well 3 is the same thing as 3 to the power of 1. So I have 3 to the power of x over 3 to the power of 1 is equal to 10, and this simplifies to 3 to the power of x minus 1 is equal to 10. So now to solve this, I'm going to take the log on both sides. So now I have log 3 to the power of x minus 1 is equal to log 10. Now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent of b to the front of the logarithm. So this is going to equal b times log a. So in this case, I have log 3 to the power of x minus 1, and we can think of 3 here as a and x minus 1 as b. So if I can move b to the front here, then so can I over here. So now I'm going to have x minus 1 times log 3 is equal to log 10. So now to continue solving this, log 10, that's the same thing as 1. So now I have x minus 1 times log 3 is equal to 1. Now, if I divide both sides by log 3, I get x minus 1 is equal to 1 over log 3. So now, if I add 1 on both sides, these two cancel out, and I'll be left with x is equal to 1 over log 3 plus 1. So now, to find the exact value, log 3, I can plug this into a calculator. Log 3, that's equal to 0.4771. So I have 1 over 0.4771 plus 1. So now 1 over log 3, or 1 over 0.4771, that's going to be 2.0959. So I have this plus 1, so my final answer is 3.0959. So this is my answer. Alright, so in this problem, I have 3 to the power of x plus 1 is equal to 12. So, let me write this down. 3 to the power of x plus 1 is equal to 12. So to solve this problem, I'm going to first start by taking the log on both sides. So now I have log 3 to the power of x plus 1 is equal to log 12. Now, I'm going to move this x plus 1 to the front, because if I have something in the form log a to the power of b, I can go ahead and move b to the front, so this would equal b times log a. So now I'm going to have x plus 1 times log 3 is equal to log 12. Now, what I'm going to do is I'm actually going to go ahead and distribute the log 3. So now I have x times log 3 plus log 3 is equal to, sorry. I'm actually going to divide by log 3 on both sides. So then these two cancel out, and I'll be left with x plus 1 is equal to log 12 over log 3. So now I'm going to go ahead and find the value of log 12 over log 3. So log 12, you could just simply plug this into a calculator. The value of log 12, that's equal to approximately 1.079. And log 3, you could also put that into a calculator, that's going to be 0.477. So I have 1.079 over 0.477, and if I divide those two, I get 1.771. Now I have x plus 1 equals 1.771, so all I have to do is simply subtract 1 on both sides, and I get x is equal to 0.771. So this is my answer. Alright, so in this problem, I have x to the power of 4 minus 25 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 here as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 25 is equal to 0. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2 I can write as x to the power of 2 to the power of 2 minus 25 I can write as 5 to the power of 2. So this is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, this can equal x squared plus 5 times x squared minus 5, which is equal to 0. So now this gives me two equations. I have x squared plus 5 is equal to 0, and I have x squared minus 5 is equal to 0. So for x squared plus 5 equals 0, all I have to do is simply subtract 5 on both sides. These two cancel out, and I'll be left with x squared is equal to negative 5. Now, I'll take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 5. And the square root of x squared is x. The square root of negative 5 I can write as the square root of 5 times the square root of negative 1. And it's going to be positive or negative square root of 5. And if you guys already didn't know, the square root of negative 1, this is actually equal to I. So now I have x is equal to positive or negative square root of 5i. So these are two solutions. Now for here I have x squared minus 5 is equal to 0. I'm going to add 5 on both sides. Now I have x squared is equal to 5. Now if I take the square root on both sides, square root of x squared is x. The square root of 5 is the same thing, square root of positive or negative square root of 5. So these are two solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent and b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I've logged 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I get x to the power of 4 minus 1 is equal to 0. Now x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to, this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, and the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these two places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now, I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20.